Welcome to this video in the Mathistry unit. This is video 2.4, where today we are going to be covering unit conversions, dimensional analysis, rounding, and sprinkle in our knowledge of significant figures, which we covered in our previous videos. And all of these things are going to be essential to our journey that we are currently taking together in chemistry class. So if you haven't already done so, please make sure you have downloaded and printed out your companion worksheet. Grab your chemistry notebook and please take notes on what you are learning. And of course, because we are going to be doing calculations, you are going to need your calculator. So without any further ado, let's get started. Let's start the party talking about standard dimensional analysis, which is essentially turning one set of units into another. And if you did the summer work, this should be pretty clear to you guys because we did throw it at you then. But in case you have some loose ends that you don't remember, this video should get you where you need to be. To remind you guys, dimensional analysis is essentially a method of setting up and solving math problems by canceling units. So it is essentially also sometimes called unit cancellation. And one of the things that is important is that it uses equalities, or what we call our conversion factors, as the driving force. And to remind you all, conversion factors are essentially 2.54 centimeters equals 1 inch, or let's say 1,000 milliliters equal 1 liter. They are equalities. At the end of the day, the beauty of dimensional analysis is that by setting your problem up correctly, using the correct conversion factors, and implementing the right numbers, you'll calculate the right answer. What's also nice about this is that we're going to put all our numbers on one T-chart and do everything in one soup to nuts operation, and that's going to help us not lose significant figures. Because I'm sure in the past, if you were sketchy on dimensional analysis and unit conversion, you were just making a bunch of proportions and choosing some random numbers to round to and then plug it into the next proportion. And in the end of the day, you were getting an answer that was a little bit off of where you needed to be because you lost significant figures. So before we dive in and try one, I'm going to give you guys the steps on how to solve these dimensional analysis problems. So make sure you pause the video now and copy these down. And once you have them committed to your notes, you can unpause and we can attack our first problem. Okay, so we're going to do this first one on our own, and we're going to sort of reference the steps as we are going through this. And you should, by the time you do, I guess, 3 or 4 of these, you will have these steps committed to memory, and they will be easy pickings for you to apply to our problems. But let's just try one together to begin with. So in our first problem, which we see here, we want to convert 0.43 ounces to grams. Step 1 of the dimensional analysis says identify the given and the want. So it looks like to me our given here is 0.43 ounces, and our want is what we want to go to, and in this case that is grams. Step 2 says mentally create a map that shows the steps to take for that conversion. What I'm thinking, if you were inside my head, is I'm trying to figure out, can I go directly from ounces to grams using any of these conversion factors here, or any that I actually know and have in my pocket? So the first thing I do is I find the given unit, and I see that ounces are here, and our first conversion factor that we're looking at is 1 ounce is 28.35 grams. So yes, I can go in one step from ounces to grams. Now, making a map is really a way of organization, which helps you understand what units actually have to go into the windows of your T-chart. This is a simple one, but they're going to get more complex later. The next step for us is to set up our T-chart, and that is probably the most important thing we have to do. So the T-chart goes like this. We are going to now draw a line like that. That's where we're going to start to place all our numbers in. And our first thing we're going to put in there is 0.43 ounces, which is our given. The given is always going to go in that top window that's there. And you'll notice there's a bottom window that's empty. Don't worry about that. This window is going to have something in it soon enough. But for these simple dimensional analysis problems where there's only one given, we're always going to put it top left. Now what we have to do is put our conversion factors into the T-chart. Now we already identified the fact that 1 ounce is equal to 28.35 grams. That is going to be the conversion factor we're going to use. So what we want to do now is put it into our T-chart in a way so that we will cancel our unit that we are given and get us the unit that we want, which is grams here. I'm going to put grams right there, and I'm going to put ounces right there. Now, by doing that, I now have ounces in a numerator and ounces in a denominator, and that is the same as if you were dividing anything by itself, giving you the number 1, which is effectively canceling that unit out. So when you cancel units out, you put slash lines through them. Super important. If you guys take a closer look at your map and your T-chart, you're going to notice that the way you have your map written will also match the units that are in the top 2 windows of your T-chart, keeping you organized. Now all that's left, guys, is to put the numbers in. Well, we know that every 1 ounce is 28.35 grams. So now it's time to do our calculation. You're going to take your calculator, grab it, put it in your left hand, and let's now plug and chug. 0.43 ounces times 28.35. I'm going to multiply across the top, hit equals. Now I'm going to say divided by whatever numbers are on the bottom. In this case, it's 1. So divided by 1 equals. And that is going to wind up giving me, for my answer, 12.1905 ounces. But wait a second. Our last thing we see here says round to the proper number of significant figures. So significant figures are going to play a role in finishing out this problem. How do we know how many significant figures to round to? The first thing we have to do is look at the given. In a case like this, our given here has 2 significant figures. So therefore our answer can't be better than the 2 significant figures we see here because we're doing multiplication and division. So I am going to round 12.1905 to 2 significant figures. I find my second significant figure, which is the 2 here. All of these are significant but don't matter. I look to the number that's next to it. It's a 1. That means leave this guy alone. And that gives me 12 grams for my answer. And that is your first simple dimensional analysis problem. Not too bad, right? Now that we got that example behind us, it is your turn to try another dimensional analysis example. This time we are going to convert 27.8 liters to gallons. Give this a shot. Pause the video now and then unpause when you have an answer. If you get stuck, just unpause the video and wait for the explanation. There'll be another one for you to try after. All right, if you were able to do this one correctly, we should have, to the proper number of significant figures, gotten 7.37 gallons. How did we arrive at that answer? Well, we're going to start with our map. In order to go from liters to gallons, I can't go directly because you'll see I got liters here, I got quarts here, I found gallons, which was here, and the problem was I needed a unit that they had in common, which in this case are your quarts. So I was able to go from liters to quarts to gallons. And what you're going to notice, as we said before, is that your map is super helpful because if you draw up your map correctly, they will always match the units that you have in the top windows of your T-chart. And that's going to help keep you organized. So the first thing I got to go do is go liters to quarts. In this case, I know that 1.06 quarts is equal to 1 liter. I'm putting liters in the denominator so I can cancel out the liter units that are in the numerator. Now I got to go from quarts to gallons. So I'm going to do the same thing. My equality is 1 gallon is equal to 4 quarts. Quarts goes in the denominator, leaving me with gallons here. Quarts wind up canceling. Then I just take my calculator, plug and chug. 27.85 times 1.06 times 1 gallon equals, remember, multiply across the top, now divide across the bottom. Divided by 1, divided by 4 equals. That got me my raw answer, which was more sig figs than I wanted because my given in this case had 3. So I had to round to 3 significant figures. The 6 is my last significant figure. That tells me here the 7 is higher than a 5. So this 6 gets rounded up and I get 7.37 gallons. Some of you guys are probably sitting at home wondering why our answer went out to 3 sig figs and not the 1 significant figure that we are seeing here. Well, make sure that you remember that conversion factors have infinity or infinite significant figures and are not used in our determination of how many significant figures to include in our answer. So the fact that there is no uncertainty in a conversion factor and it has infinite sig figs leaves us only the given to determine how many significant figures to report our answer to. All right, on to question B. It is your turn to turn 58,600 decimal point pounds to milligrams. So pause the video now, figure out your map, set up your T-chart, and calculate to the proper number of significant figures. When you are done with that, unpause the video and then check your answer. Okay, if you were able to do that correctly, we should have gotten 2.6636 times 10 to the 10 milligrams, which is out to 5 significant figures, given that our given had 5 sig figs. Remember, that decimal point makes all of these trailing zeros significant. That is important. Don't get fouled up by that. Last one of simple dimensional analysis for you to try. Let's turn 4.3 kilometers into inches. Pause the video now and then unpause when you have an answer. Got that one right. We should have gotten 170,000 inches, or since we are reporting to two significant figures, we could have actually reported it in scientific notation, 1.7 times 10 to the 5 inches. Either one would in fact be appropriate. If you got any of this stuff wrong or you still have questions, make sure you make a note of it and you bring it up when we convene tomorrow. Okay, let's take it a step further and jump into even more dimensional analysis. We are going to be introducing you guys to what we call rate conversions. And what a rate conversion is essentially a change that you see over time. So we're seeing that here. This is different than standard dimensional analysis because we were converting milliliters to liters to ounces to gallons, whatever. But in this type of dimensional analysis problem, we actually have two units that are here in a ratio. So it is in this case a volume over time, or in this case a distance over time. And when you do these problems, you may have to actually convert one of these units, leaving the bottom one or the top one, or convert both to something. So in order to get you guys comfortable with this, I am going to do a problem with you all, show you the strategies, and then set you free to try some on your own. The first thing we have to do is to identify our given, which is 70.01 miles per hour. We have to figure out our want, which is what we want to go to. And then, of course, like we did before, we have to make our map. So let's make a map here. And this is going to be the first thing that is different. And I'm going to do it in two different colors that you see here. So in terms of our map, we have two conversions to make. We want to turn miles into feet, and we want to turn hours into seconds. So let's concentrate on doing miles first. If we wanted to turn miles directly into feet, is there a direct conversion for that? Or do we have to go through a couple middle conversions as we go? Well, when I go up here, I see that 5,280 feet is equal to 1 mile. So it looks like to me, I can go directly from miles to feet. Looking at hours to seconds, there is no, well, I guess there is technically a direct conversion, but what I'm always going to tell you is make your life easy. Go step by step. You come into this class with knowledge of how many minutes in an hour, how many seconds in a minute, etc. So these are things that you can leverage in order to turn these units from what you're given into what you want. So we are going to go from hours to minutes to seconds. So you're going to see this is a 3-window T-chart that's here. So now that we've figured out what our two conversions are, you have to set up a T-chart and you have to attack them one at a time. So let's make our T-chart and let's put our given in, 70.01 miles. And miles is going to go on the top here. And remember that bottom window which had nothing? Well, we are going to now put our other unit in, which is hours. Now we need a number for that. Since it's miles per hour, that really means per 1 hour. So we're going to put a 1 in there. This has infinity sig figs in it, that 1 hour, because it's per hour. It was the result of a calculation with no doubt. This is still a measurement that has 4 significant figures because somebody measured that. We're going to come back to that later, but just for now, I wanted to get you guys understanding what's going on. Let's now convert miles to feet. What's going to cancel miles? Well, we know it's going to be miles. And since our map usually matches the windows in our T-chart, we are going to put feet here. Here is our equality, feet and miles. How many feet equals how many miles? We know 1 mile is 5,280 feet. Miles now cancel, and we're left with feet per hour. That's not what we want. We want feet per second. So that means we have to do the rest of this calculation. I'm going to change the color just to make it a little more visible for you guys. Let's do this in purple. And so now we want to turn hours into seconds, but we got to go through minutes first. So what's going to cancel hours? It's going to be hours. So we're going to put that here on top, and then we're going to put minutes on the bottom. What is the equality? Well, every 1 hour is 60 minutes. Hours now cancel, and you will notice that our T-chart is looking like hours, hours, minutes, minutes. Now we got to go to seconds. What's going to cancel minutes here? It's going to be minutes, and that's going to leave us seconds here in the denominator. Minutes and minutes are going to cancel. Let's throw some numbers in. We know that in 1 minute there are 60 seconds. So we now have the units that we want. We have our feet and we have our second, and that's what our desired want was. Now it's time to pick up your calculator, put it gently in your left hand, and let's calculate. 70.01 miles times 5,280 feet times 1 hour times 1 minute equals, so we multiplied across the top, now we divide across the bottom, divided by 1 hour, divided by 1 mile, divided by 60 minutes, divided by 60 seconds, and that gives me an answer without significant figures, which is 102.681333 feet per second. But what we want to do is now turn that into significant figures. So let's change the color for everybody with that. And let's make this a nice crimson. We saw here our given had 4 significant figures. And this given had infinite, so we are going to disregard that. So what we're going to do now is find our 4th sig fig, our first, our second, our third, our fourth. So that's as far out as we want to go. So we got to look to the number to the right of that, which is 8. That says we're going to take that 6 and we're going to make it 1 higher. We get 102.7 feet per second. And that is our significant figured answer and our first example of rate dimensional analysis. Now it's your turn. Give yourself a chance to try and solve this problem, turning liters per second into gallons per year. So identify your givens, your wants, make yourself a map, set up your T-chart, and make sure you are canceling units. Pause the video now and then unpause when you have an answer. All right, if you did that correctly, you should have gotten 32 million gallons per year. Boy, that's an awful lot. And that is to 2 significant figures because our given here had 2 significant figures. Remember, this is per 1 second, no uncertainty. So we have infinity sig fig, so we disregard that. You could have probably put this also into scientific notation if you so desired. But we left it in standard. It doesn't matter. As long as you have 2 sig figs for your answer and your answer matches the magnitude of your answer here, everything should be a-okay. So that is it for your rate calculations. That wasn't too bad either. Hopefully you are mastering these skills. And as always, if you have questions, bring them up in our next session when we convene tomorrow. So the final part of this video is going to involve even more dimensional analysis, and it's going to focus on converting between squared and cubed units. What's nice about this is it's going to involve many of the things that you previously learned as far as unit conversions go, but it's just going to put a slightly new twist into it. In order to ease you in, let's have you go backwards and do some standard dimensional analysis and convert 5.936 inches into miles. Pause the video now and do that to the proper number of significant figures. Unpause when you have an answer. So if you did this correctly, you should have a map that looks like this, going from inches to feet to miles. And your dimensional analysis should have 3 windows, just like your map does here, and should get you an answer that is 9.369 times 10 to the minus 5 miles. Now let's take this problem and everything we did in it and expand it to deal with the cubed and squared units. So here's the T-chart that we just created, and we're going to keep this here just to reference it. And I know I pulled out the conversion factors, but you guys already know what you need. And so we're now going to implement it into our new T-chart that we're dealing with here. If I were to solve this problem, you will see the only difference is we are now dealing with cubic inches and cubic feet and cubic miles. So to show you what I would do on this T-chart, you will notice that I have the identical same conversion factors. 1 foot is equal to 12 inches. 1 foot is equal to 12 inches, except that I have them now in sets of 3. Why I'm doing that is because I need to cancel cubic inches, so I need to have them 3 times. So one of these would cancel one of those inches, leaving me squared inches. The second one gets rid of the square, leaving me inches, and then the last one gets rid of the inches, leaving me with cubic feet. You'll also notice that I then had to put the conversion factor from feet to miles in 3 times in order to cancel all those different feet and replace them with miles. And when I multiply miles times miles times miles, I get cubic miles. And then when I do the math on this, I wind up getting a really long answer, but I got to go round that now to 4 significant figures because I got 4 significant figures that are there, and that gives me 2.334 times 10 to the minus 14 cubic miles. So the big takeaway from this is all the dimensional analysis is the same. All the entering into the calculator is the same. It is simply the repetition of your conversion factors, which we have to do in order to cancel the units that we are given. So for instance, if this was maybe squared units, we wouldn't have to do it 3 times, we would do it twice. Don't worry about ever having to go between squared and cubed units. That'll never happen. If you are in a unit of volume, you are going to continue converting it to a unit of volume. If you're in a unit of area, which are your squared units, you will stay within that unit of area and have nothing to worry about. So now it is your turn. Let's take this area of 123.40 feet squared and convert that to millimeters squared. Make yourself a map. Be careful when you do this. Make sure units cancel and make sure we have the proper number of significant figures in our answer. Pause the video now and then unpause when you think you got it. So if you did this correctly, we should have a map that looks like this, going from feet to inches to centimeters to millimeters. Of course, they are squared. And when I make my t-chart, it should look like this, giving me an answer to the proper number of significant figures. We are going to need 5, and the calculator should give us 11,464,000 millimeters squared. Or if I wanted to, I can go into scientific notation with that and call it 1.1464 times 10 to the 7 millimeters squared, giving me the same number of significant figures. So that is squared and cubed units. Make sure if you have any questions on this lesson that you bring them forward in the Burning Questions segment tomorrow when we reconvene as a class. It is an important skill, this dimensional analysis thing, which will weave its way in and out of many units in our chemistry class. So that is it for me. It has been a pleasure taking you through this. I hope you have acquired some new skills. And of course, I will see you on the flip side tomorrow. Peace out.
That's all, folks.